Alright guys, what is up? Welcome back. Sorry, no funny intro, I just gotta go ahead and get these done. Finally got a setup at home that's working, I think, so we're gonna go as fast as we can here. Well, I mean, reasonable speed, I guess. Guys, the very next section of this is 5e. Wow, so pretty. Solving problems using special right triangles and the Pythagorean theorem. I think this was our least favorite unit from the entire year. I'm not sure why special right triangles in the past has been difficult. When I taught geometry before, this was also a typical, like, what's the word I'm looking for? Like, this is the typical place people struggle in geometry. So if this is tough for you, please do not feel bad. Alrighty? Totally normal. Totally normal. Let's see mine. Just dug a highlighter out of my old box. Let's see if that thing works. Oh, yeah. Look at that. Okay, anyways. So, what I'm thinking is, and also I think I'm getting sick, so I'm sorry if I'm sniffling into the mic, but that's all I got going with me. Also, this mic was $4 at Best Buy, so I already know this quality is about to be wild. Anyways, so the special right triangles. There are two special right triangles. Before we actually do this section, let me draw up here. This is the notes recap from the section. There are two special right triangles. One of them is isosceles. It looks like this. Alrighty. The other one is scalene. Looks something like this. Alrighty. This guy is special because he's half of a square. The reason we call it a special right triangle, right? He's special because he's half of a square. So that means this side, whatever length this is, like for example, if it was length x, this side would also be length x, making these two edges isosceles. Very nice, very nice. Okay? And so, if you do the Pythagorean theorem and calculate it, it works out that this side ends up being x times the square root of 2. Ready? If you want, you can prove this to yourself using the Pythagorean theorem. Right? And remember, the square root of 2 is just 1.4. I just realized I don't have a calculator, so I can't show you guys what the square root of 2 is. Okay, but I promise it's about 1.4. Alrighty? It's about 1.4. So if this side is x, this side is x, this side is about 1.4 times x. And this works for any triangle that's half of a square. Okay? And this ends up making these angles 45 and 45, since it's half of 90, right? Anyway, very cool, very cool. Alrighty. The other special right triangle is the 30, 60, 90. He's special because he's half. I don't need to draw over the instructions here, but this guy's special because he's half of an equilateral triangle. So if this big triangle with the dotted lines has all three sides the same, then you might call this side x or something like that, or like s or whatever for the side length. Alright, and actually just to indicate that it's a different length here, I'm going to use the letter y. So like for example, if this short leg was y on the triangle, then this length would also be y, this piece here. And that means the hypotenuse has got to be 2y. Very cool. And so if you do the Pythagorean theorem here, we'll take 2, you could do like 2y squared minus y squared, square root of those. And this gives you the square root of 3 times y, or y root 3, it's often said, on this side. So basically, across from the 60, that's y times the square root of 3, which is about 1.7. Ready? And then if you go from this one, I'm sorry, if you guys can hear my cats, bro, I'm so sorry. They're screaming. They're livid right now. Across from the 30, over here is y. Alright, anyways. So these are the two special right triangles. So if you ever see triangles that look like half of a square, you don't have to do the Pythagorean theorem. You don't have to do trigonometry. You don't have to go through and labor through all these processes. You can just know what the answer is, right? And the same thing is true for the 30, 60, 90, which is half of a equilateral triangle in any case. So if we see this in action, the 45, 45, 90 is half of a square. So this means if this side is 17, this side's also 17. Bam, there's one answer. Okay? And to get the last side, you could do the Pythagorean theorem if you wanted to. Always, of course. It works on any right triangle. So you could do it here if you wanted to. Ready? I'm going to cheat. since I know, look, here's this triangle, this exact same one. Since I know if this side is x, this side is 1.4, or the square root of 2, times x. So this side's the same. Y is, in this case, 17 times the square root of 2. Or often it's just said 17 root 2, the exact form of that answer. Box it in. That's all there is to it. You ready? Guys, if this is too hard, then you are doing too much. Alrighty? If this is too hard, then you are doing too much. On the final exam, this will be what's it called? Multiple choice as well, so that'll hopefully help you a little bit. Anyways, same thing for this guy, except it's a little bit different. Here we have the diagonal of the square. So like if this was half of the square, then this piece would be the diagonal. So on my picture over here, that's this piece. In other words, 14 is equal to x times the square root of 2. And so, if I want to get x here for this side, excuse me guys, so sorry. We're going to divide both sides by the square root of 2. Look at that. How lovely. That's all there's to it. Now, this is not the exact form of the answer. So what you could do on the calculator, you could, and honestly, let me just pull up a calculator. I'm sure I have a calculator on my computer. We have to use the age-old scientific calculator. Yeah, boy. Look at that. Oh my gosh, it even has a trig function. No way. They have updated this. Windows 11. All right, anyways, so on my calculator here, I'm going to type in. Let me see if I can show my actual notes here. You could look on the answer sheet, or sorry, on the answer choices for x times the square root. Oh my god. It's reverse Polish notation. Let me clear all this. Sorry guys, let me start over. First, I'm going to say the square root of 2, which is, see, I told you guys 1.4. Look how accurate that is. Wow. Square root of 1.4. And then we are going to take 14 divided by this number. So 14 divided by, and I think there's an answer on here. Look at us learning together how to use my calculator here. I wonder if there's a better one. Oh, here we go. Maybe I just want standard. Oh, no. I need the square root, so we're going to take the square root of 2. Alrighty. And then we're going to reciprocate that and multiply by 14. Alrighty. So basically, I'm just taking 14 divided by the square root of 2. Alrighty. And that's about 9.899. So you could approximate all the answers on the formula sheet and look for that exact answer. Or you could just remember how to simplify this guy. 14 over the square root of 2. We can rationalize this denominator by multiplying root 2 over root 2. Whatever's easiest for you. And then here, root 2 times root 2 on the bottom, that's just 2. And maybe I could prove that to you guys. Of course, it's the opposite of squaring, right? So if you take the square root of 2 here. Oh, I squared it. We added it backwards. Clear that. If you take the square root of 2 here and multiply by the square root of 2, so see in my top here I have root 2 times root 2. That's 2. No way. And then on top you have root 2, and then 14 divided by 2 is 7 root 2. Alrighty. So essentially, either of these answers is acceptable for x. It could have been that one or that one. So we'll just write out x equals 7 root 2. And look, if x is 7 root 2, then this is half of a square, so this side's also 7 root 2. That's all there is to it. Look at that. Very nice. So let's keep going here. Turn the page. We'll try some 30, 60, 90s too in a second. Alrighty. And just to leave you guys something to do, I'm going to keep working. I'm going to skip over to the 30, 60, 90 now. And it's the same business. So let me look. On the formula sheet, you could look over and see this guy's actually given. And I believe it's written, I believe on the formula sheet it's written like this. If this were x, then this would be 2x, and this would be x times the square root of 3. This is the 60. This is the 30. So across from 30, that's the small side, x. Across from 60, that's the bigger side, x times the square root of 3. And so, let's see. To be able to use this, I'm actually going to look here first. This side happens to be x, right? And then check this out. If this is half of an equilateral triangle, right? Then this height of the triangle, has to be x times the square root of 3. So I'm just going to write that down. Y must be 22 times the square root of 3. And then same thing for this side. This side is twice as big because it got doubled to make the equilateral triangle, right? And do you guys see the equilateral triangle? And then look, this edge is 2 times x. So this side has got to be 2 times, and r was 22, so this is 2 times 22, or 44. And so for our answers, like if you were looking for an answer choice, it would be the choice containing both of these. You know, so on the test it'll look something like this, like a x equals root 44. Sorry, excuse me, 44y equals 22 root 3. Alright, this is the one you're circling. Alrighty. So let's keep going. Let's try number 22 here. Same kind of deal. Now in this one, it's kind of weird. We know this edge. So if I were to draw in my triangle, if I were to duplicate this, there's my equilateral triangle. If these sides were all 34, alrighty, then how much does this side have to be? Well, it must be half of 34 since I duplicated this into 2 equal pieces, right? So 34 divided by 2, that's 17. Very nice, very nice. And then same thing here. Look, this is the height of my triangle. So if I look on my picture, here's the height of this triangle. That's x times the square root of 3. Alrighty? So note, look, you got to be careful here. We went from here to here first. So we took half of 2x and got x. Half of 34 and got 17. Now we need to use 17 to get the height. In other words, the short leg, the one across from the 90 the 30, the shortest leg, the one across from the 30, is what we're going to use for y. And so y must be 17 times the square root of 3. Look at that. All right. Very, very similar for this one, I will say. On this one, 12 is going to be equal to x root 3. And it'll be up to you to solve for x here. Alrighty? That is all for special right triangles. Let me know if you guys have any questions.